Good morning, everyone. Mayur, is my screen visible?
Yeah, you are visible, Monu.
Yeah. Good morning, everyone. So today I'm going to present about parallel application in MySQL and MariaDB. Before we start to our technical presentation, let me introduce myself and my Mydbops. Yeah. So it's about me. Yeah, about Mydbops. So we founded in 2016. Since 2016, we have providing assistance. We are providing assistance to many organizations, scaling their database to improve their performance, database performance, scalability. Scalability in terms of to find their bottlenecks of their architectures and defaults in their architectures. Um, we have a 70 member plus team. All are certified DBS and database engineers. We have assisted on the top many clients, like 500 plus clients, and we mostly provide services on the top open source database like MySQL, MongoDB, and Postgres. Beside this, we are also AWS partner and PCI certified organization. Yeah, so MyDB services. So we are providing two types of services: database consulting services and managed database services. Yeah, so these are a few of our clients. Yeah, so agenda for today is what is replication, evolution of replication, parallel application in MySQL, and parallel application in MariaDB. Yeah, so let's start with our first topic. What is replication? So basically, replication is a data copy process among the servers to keep them in sync. So and it is native and inbuilt feature, and it is asynchronous by default. It means like a master will not worry about the slave, whether it has received the transaction or whether it's applying those transactions. And it's logical in nature, like a SQL statement will apply from master to slave. It is one of the most popular feature among the open source databases, and this is a basic replication flow. So source and replica. So source will write its data changes in the bin log, and from bin log IO thread will read it, and it will write into the relay log, and from relay log SQL thread will read it and write to the replica. This is a basic architecture. Advantages of replication. So load distribution means we can have multiple replicas which can be used to handle the read request. As normally, if we have standalone, then writes and read will be come to the master, so that can decrease the performance. So to scale out, we can have the multiple replicas which will serve the read request. It is replicas can be used for backup and high availability. We can have our backup configured on the replica. So in because backup process will also consume some resources. So if it is master, then it will take some resources that will affect the server performance, and it acts as a high availability also. If we have multiple replicas, then if suppose our master goes down, then that replicas to uh, we can use that replicas to promote as a master. And replicas can be used for analytical purpose. Long distance data distribution means we can have the local copies of data that can be used for the remote sites instead of directly accessing the source. Delayed replication, this is one of the prominent feature, like we can have the delayed replication between master and slave. So we can define the duration between the delay duration between the master and slave. So it will if it's something unexpectedly happen on the master, during that delay duration we can roll back from the delayed slaves. Yeah, so method of replication. Replication is two types of methods, basically two types. We will configure replication with two types, like binlog position based and GTID based. Binlog position based we will configure using binlog file positions and binlog file names and positions, and GTID will be like global transaction identifier, that will be unique transaction identifier across the server. Yeah. So evolution of replication in MySQL. Evolution of replication in MySQL. So from MySQL 3 to 3.23, the replication was only single threaded, means just it has only one thread. Means there was no concept of IO and SQL thread. It came into MySQL 4 that boost the performance. And till 5.5, the replica the till 5.5, there is no GTID or there is no parallel replication. It was based on only IO and SQL thread, and it is having only file name and position based replication. From 5.5, it's there is a lot change, means GTID came in a picture, and parallel replication introduced. MySQL 5.6 is a multi-threader on base of database level, means per database level, like all the transactions will be tagged with some database name, and those transactions will be applied parallelly on the slave. And from 5.6, it has been based on logical clock, like parallel application based on logical clock. And from MySQL 8, right side based replication has evolved. Yeah. So cons with single threaded replication. So lack of resource utilization, it means like if we have a multi-core machines, like multi-core CPU machines, then slave will do apply all the writes sequentially, so it will not efficiently use the hardware. So that is one of the con. And if it's slave is single threaded, then there will be definitely lag on the servers, and for getting that lag sync, we have to wait. And because of this, if there is a situation like we have to promote a slave to a master, then this can't be possible immediately. So let's discuss about the parallel application. Parallel application flow. So to source and replica. So source will write all its data changes except the select. All data changes will be stored in the binary log, and that binary log will be get read from IO thread, and that will be write into the relay log. From relay log, it will be taken by SQL thread, and it will be given to the worker thread cache that will have the jobs in queue, which will allocate all the jobs to the worker threads of the replica, and that will apply parallelly. So this is a change it happened in parallel application. Previously it was SQL thread directly applying all the change on the replica, but now a worker thread cache will allocate the jobs or events to the worker thread to apply it parallelly on replica. Yeah. So we will discuss about parallel application in MySQL 5.6, MySQL 5.7 and 8.2. So parallel application in 5.6, parallel application is based on schema level. Like if it will be like parallel application will only apply when we have multiple schemas, or when we have a like environment where we are using multiple schemas. It can't be applied on a single schema which have many tables, and writes are coming on those many tables. Those all will be sequential. So it's like two transactions on different schema can be run in parallel on slave. So these are the variables we should consider while enabling the parallel application in 5.6. So slave parallel worker, we should set it at greater than 0, and it's dynamic. We should set it at greater than 0, then only the worker thread will get allocated. And slave pending job max size, this will define the memory size in bytes that can every worker thread can keep those pending jobs in queue. And relay log info repository and master info repository both should be in table. This both will store the like positions, like relay log will store the replicas relay log informations, and master info repository will store the masters IO threads information, like master which masters binary log and positions, binary log files and position. So this should be in table. So like it should not be in file. Like if it's in file, then the commit, so that the file writes to the disk will be by the OS levels. But if it's in stable, then this will be it will have the more recent updates. So there is a less chance like it will miss any positions or anything. Real log recovery should be on. So this will avoid the inconsistencies of IO thread when the server starts, and it will handle the gaps in the transactions. Yeah, so cons of parallel application: transaction ordering can be different on master and slave, and gaps in transaction order. Gap means like suppose there is a transactions which are applying in a sequence, but the transaction has applied, but maybe there can be a chance like the later transaction which came later have applied, but the old transactions are still in the queue, it has not applied. So this can be gaps can occur, and this can happen when there is multi-thread is enabled, like when there is slave parallel worker is enabled and parallel application is enabled. So avoid this gap, we should either set like a slave preserve commit equal to 1, that will preserve the commit order. So it will commit the transaction on slave on the same order as on master. Parallel application was not crash safe without GTID. Like if it's a normal file based of file and position based application, then then there is a chance like when the server crashes, there is a chance like some transaction will missed. So if it's a GTID, so it will compare the GTID executed position. So there is a very last chance like if any transaction got missed while during the crash, and it will already executed, GTID will already executed, so it will compare the position between master and slave. MySQL 5.7. So parallel application was on intra schema level. So in 5.7, like it is not like 5.6, like it is on per database schema level. It will be like even if the database has the 100 tables or 1,000 table, the transaction on those table can be applied parallelly on the slave by the parallel worker threads. This is based on binlog group commit information. Binlog group commit information, if the whatever transactions are grouped together based on this last committed and sequence number are applied parallelly on the replica servers, and this can be enabled by setting slave parallel type is equal to logical clock. That is basically it's a tracking all the transaction based on its timestamp and making the groups. And second option is database, which is by default as a 5.6, which will do the parallel application based of per database level. And yeah, and binary log events will have all the events will have some associated last commit and sequence number that is useful to grouping the transaction, so that group can be committed together on the master. So the same can be applied, the transaction from that group can be applied parallelly on the replica. And slave preserve commit to avoid the gaps. We should enable the slave preserve commit to avoid the gaps, so that can maintain the proper order, like proper order from relay log to replica while applying the transaction. So variables to be considered while enabling the parallel application in MySQL 5.7. So first is slave parallel type, that is logical clock, we have to set it, and then slave parallel worker, it should be greater than 0. Then slave preserve commit should be 1, should be enabled. And these two variables, binlog group commit sync delay and binlog group commit sync no delay count, this should be fine tuned on master based on the workload. First is like how many microsecond we can make the group transaction or to commit those transaction are the group to commit delay, means how many microsecond we can make it delay. And second one is like binlog group commit sync no delay count will give the number of transactions that we have to delay, that we have to make them delay for committing number of transactions. It will define the number of transactions. So this should be tuned on master based on the workload. Yeah. So parallel application cons, like optimizing the binlog group can slow down the writes on master. Like if we delaying the commits on the master, then definitely real-time application will not work as expected. So it can eventually affect the application also, delaying in committing. And slave preserve commit, we have to enable the slave preserve commit to make the commit order to make the proper commit order and avoid the gaps. So that requires to enable the bin log and log slave updates. And when we have a master slave, and under that slave there is one more slave, that middle slave will act as an immediate like a relay slave, then this can be this can work. But if we are having only just master slave setup, then that time enabling the binary log will be an overhead. Like we have to maintain again the binary logs. It will consume the space and resource. Longer transaction can cause blocking and slow down the parallelism. Like transaction like alter, if we executed any alter, then definitely it will not go in parallel. It will not apply in parallel on slave. It will go in a sequential manner, and till the time the transaction process on the slave, all the other workers will be waiting state. It will not like it will wait. It will it will wait till that alter got complete. So that can cause an unnecessary delay. Yeah, parallel application in 8.0. Parallel application in 8.0 was using write sets, like bin log transaction history, dependency. There is a variable which we have to set it at write set, and write set is basically a set of transaction, and transaction that affect the different row can be parallelized. Means the rights in the different rows can be used to parallelize on the slave servers. And this dependency information generated from the source write set, like from the source binary log, it will write those rows, those affected rows that can be applied parallelly on the slave. And this is a mechanism, like a write set is a mechanism to track the independent transaction from the master's bin log that can be applied parallelly on the slave. And this is a faster method, faster application method in MySQL till now. Yeah, so variables to be considered. First variable is slave parallel type. Second is slave parallel worker. So to enabling the parallel application in MySQL 8, we should set the slave parallel type as a logical clock, and slave parallel worker should be greater than 0, and bin log transaction dependency tracking should be write set or write set session. So a write set is basically like the transaction which affect the different tuples, different rows, that is a write set or a set of transaction. And write set session, like in the same session, two updates cannot be reordered, or cannot be reordered or cannot be applied from the same session. Transaction write set extraction, this is an algorithm like how to hash those transactions, how to extract those transactions that can be used for parallelism. Slave preserve commit order, as it's like it will preserve the commit and it will avoid the gaps between the transaction. And as the info I have mentioned, like this transaction means these variables will be from 8.0, it will 8.0 to 27, it will be by default. So from 8.0 to 27, by default the replication will be in parallel in the slaves, like this all variable will be enabled. And master info repository and master relay log info repository will be table from 8.0 to 23. It will be by default table. There will no option for files. And relay log recovery will be should be on. We should consider it as on to avoid the inconsistencies and up the servers without any issues with IO threads. Yeah, so limitation of parallel application in 8.0. So like we should have all the tables in InnoDB. Primary keys needed on all the tables. Do not work well with the foreign keys relationships. And slave parallel workers should be greater than 0. And it will be work efficiently with row-based replication, which is default in 8.0. Parallel replication. Recommendation for efficient MySQL parallel application. All the table, as I told earlier, like all the tables should be in InnoDB engine. All the tables should have primary key. Enable GTID for crash safe replication to avoid the inconsistency or missing any transaction during the crash. Relay log recovery should be enabled. Set slave preserve commit to 1 to avoid the gaps, which is default from 8.0 to 27. row-based replication is faster and better as compared to statement-based. And master info repository and relog info repository should be table, which is default from 8.0.23. These are the some general recommendation for efficient to applying efficient MySQL parallel replication. So now we will move ahead with evolution of replication in MariaDB. Yeah. So before MariaDB 10, the replication was single threaded, same like MySQL 5. Like it doesn't have a parallelism, and it works like a same MySQL file, like same. There will be no worker threads, and it will same like there will be IO thread which will read the binary log, and it will write into the relay log, and from relay log, SQL thread will apply to the data slave database. But but after MariaDB 10, parallel application was introduced, and it has the like it has very like two types of parallel application can be possible in MariaDB, that is in order and out order. So till 10.5 there is a in order parallel application type conservative, which was by default, and after 10.5 optimistic become the by default. So in this way they have changed the parallel modes and parallel replication types. Yeah. So parallel application. So parallel application MariaDB, it has, as I told, it's introduced in 10.0.5, and yeah, it required both the version, like master and slave should be more than 10.0.5. And from MariaDB 10, the events are applied by the pool of separate replication worker thread on the slave. Means like they have the worker threads. There means all the events which should be which is applying parallelly on the slave by the parallel worker thread, and that will be get enabled after enabling making this variable more than 0, like slave parallel thread. And this parallelism will work by reading ahead in the relay log and allocating those events, those queue events, to the worker thread that will apply parallelly on the replica. Yeah. So parallel replication in MariaDB, it is two types, like in order or out of order. So in order basically maintains the same order, maintain the same commit order that happened on master. It will maintain the same on slave also. But out of order, it will not maintain those same commit order. It can be different order. Commit can be in different order. Transaction commit. So parallelism is completely transparent to application in the while considering the in order, but in terms of out order, application must be tolerant to accept the updates or transaction commit in different order or maybe in random order. Yeah. So these are the modes of in order replication. First is optimistic, aggressive, conservative, and minimal. So we will go one by one. Yeah. So optimistic mode, it introduced in 10.1.3. So here like as it's an in order replication, so it will preserve the same commit order what happened on the master. It will apply in the same way. So parallel replication can be applied on the slave while still preserving the exact transaction semantics. That here the term optimistic itself, like server will assume, like when we set this slave parallel mode as optimistic, then slave server will assume like there can be conflict, and conflict will occur. Definitely there will be conflict occur, and it will try to handle it by rollback and retry. Means if there is a two transaction which tries to modify the same row, then in that situation the transaction which came first will be commit first, and the transaction which came later has to wait, and then it will retry and it will get committed. So rollback and retry occurs when there is a conflict, and non-transactional DML and DDL is not safe to be optimistically applied in parallel. Like if there is a table with a different engine other than InnoDB, which is non-transactional, then those transactions will not apply optimistically in parallel because those cannot be rolled back. And transactional DML is allowed to run on the parallel up to the limit of slave domain parallel thread. The slave domain parallel thread will define on the base of the domain ID, replication domain ID. Suppose we have a multi-source replication, then there will be two master on one slave. Then both the master will have some different domain ID, and for those different domain ID, the slave will have different pool of worker threads that will be defined by this variable, slave domain parallel threads. Yeah. So now aggressive mode. Aggressive mode, it also introduced in 10.1.3. It is similar to optimistic. Just the difference is that whatever conflict occurred on the master, it will not decide on base of that. Previously, that optimistic will means handle the conflict as a handle on the master, same on the slave. But here it will be not in that case. It will not worry about the transaction which has conflicted on the master. It will apply those transactions which has the conflict in parallel without worrying about the conflict on the master. And this tries to maximize the parallelism at the cost of increased conflict rates. Yeah. So conservative mode, so it introduced in MariaDB 10. So it is basically same as MySQL 5.7 logical clock based on the group commit. So all the transactions which has the same commit ID will form a group and committed together on the master. And those committed together on the master, those group of those transactions, like those transactions which are in the group, can be applied parallelly on the slave. And this every will will capture even every event with some commit ID, and those commit ID can be used to make a form a group. The events which have the same commit ID can be used to form a group, and those group of transactions or those group commit can be occur on the master, and same can be replicate parallel on the slave. And here conflicts are avoided, means it will, if two transactions has committed separately on master, then committed separately on master, then it will not on the replica, it will not it will avoid those conflicts. Like it will first it will allow the first transaction to get committed, then it will allow the second transaction to get committed. So second transaction has to wait till the first transaction has committed. So in this way, the conflicts are handled in the conservative mode. And will not commit wait count and will not commit wait u second, means microsecond. So these are the variables which we can consider for tuning on master. To more effective to have the more effective will not group commit. So will not commit wait count will decide the number of transactions that we want to make in a single group, and to have a delay commit on the master. And will not commit wait u second means it will decide the number of seconds or number of seconds in microseconds that we want to delay in committing the group of transaction. So and this means this to avoid the conflict, it limits the parallelism. Means if there is a conflict and the two transactions have modified the same row, then that time it will go in a sequential manner, it will not go in a parallelism. So that limits the parallelism in conservative mode. MariaDB minimal mode, this is third mode, minimal mode. So it is it is same, it will make in a transaction will commit in the same order, but here commit step of the transaction can be parallelized on the slave, but other steps other than commit will not be parallelized, it will be in serial or sequential. And this can be enabled by setting slave parallel mode system variable to minimal. So this is a second type of parallel application in MariaDB, out of order. As the name suggests, it will not preserve the commit order same as master, it can be different. And it will enable when this replication when happen only when there is a GTID mode enabled, and that is by default from 10.2 in MariaDB. And every transactions having the GTID with different domain ID will be applied in parallel. So different domain ID means if we have a multi-source replication, then for every master there will be different domain ID. So those type of transaction will be applied parallelly in slave. And here applications has to set the different domain ID for transactions that are truly independent to each other. Means here application has also should be tolerant to set means should be tolerant to accept the transaction in different order, and setting the domains ID for the transaction. and so there is application dependency here, and transaction with different domain ID are committing in different orders. Like it can be like uh, like when we have a master slave, two master and one slave, like multi-source, then with different domain IDs, the transaction will associate with different domain IDs, can be commit in different order. That will be no conflicts, or that will be no waiting for each other. It can parallelly apply on the slave, because as it has a different domain ID, so worker thread will take it separately and apply it on the slave. And this is more effective for long running statements like alter from separate replication domain. So this will also, like if we have a multi-source replication, then suppose in one master we have executed one alter, and so that alter transaction will have tagged with some domain ID, that GTID will have tagged with some domain ID, and that will be not same as the second master. So that transactions will be taken care by one worker thread, but other worker threads will be available to take the other transaction from other master. So there will be like no waiting state for, like if normally if we have a there is no domain ID of different domain ID, then that worker has to wait till the alter got complete. But here, as it's a separate domain ID, so workers can be allocated to apply the other transaction other than this alter to parallelly on the replica, and it's work efficiently for multi-source replication. As I told, like it will more benefited in multi-source replication, where we have a different replication domain ID. Yeah. So variables to be considered while enabling the parallel replication in MariaDB: slave parallel threads that should be greater than 0, slave parallel mode should be optimistic, conservative, aggressive, or minimal. That we have to set. By default it will have conservative till 10.5, and after 10.5.1 it will be optimistic. Slave parallel max queue, this will define this variable specifies the size in bytes that can keep the transaction in, like pending transaction in queue. Those can be allocated to the worker thread to apply parallelly. Slave domain parallel threads, as I told earlier, like this will be more dependent on when we have a like multi-source replication, and each master will have different domain ID. Then in that case, the replica which is accepting the transaction from both the master will have can allocate different pool of worker threads to each domain. Like for each master it can allocate the pool of threads, and this should be less than the slave parallel thread, then only it will work. It should be not more than slave parallel threads. So variable comparison between MySQL and MariaDB. So these are some few variables which are equivalent to MariaDB. This MySQL variables are equivalent to MariaDB. So slave parallel threads, here it says a slave parallel worker, slave parallel type, there will be slave parallel mode, slave parallel job size max, and here will be slave parallel max queue. So both are equivalent to each other, and both doing the same tasks internally. Yeah, and same way, like for build log group commit sync delay, and build log group commit sync no delay count. So same way in MariaDB we'll have build log commit wait second, that will also, both will be in microsecond, and build log commit wait count, that will decide the number of transactions we have to wait to apply the commit. Yeah, so these are the references which I referred. Yeah. Yeah. So yeah, thank you.